tryout in phase 3 will allow us to gather data, to collect data for us to run item analysis. So in the phase 4, in the item analysis sections, item analysis refers to a statistical methods used to evaluate the quality as well as the effectiveness of test items. So here, some books combine both item analysis and tryout in one stage. However, the books that we referred to, Cohen et al. 2022, consider these two as different phases of test development. Item analysis helps test developers to determine whether each item contributes to the overall validity, reliability, and fairness of the test. So the purpose of item analysis is to evaluate the quality of test items for its final selection of the final versions of the test, or to identify items that require further improvements. So as an evidence of validity, we would compile all of these processes. So item analysis gives us a concrete evidence, statistical evidence, that shows that certain items contribute strongly to the conceptualizations of the test, and certain items may not necessarily achieve its objectives. Hence, these items may require further clarifications, adaptations, enhancements, or maybe we need to omit them from the final version of the test. So item analysis serves a very big purpose because it provides concrete validity evidence whether the items serve its purpose that provided or contain quality and effectiveness. In some test development textbooks, they differentiate two approaches to item analysis based on the two best theories in psychometrics, which are classical test theory and item response theory. However, in this brief video, I'm going to only explain about item analysis based on CTT, classical test theory. So under CTT, we can develop 4 indices based on item analysis procedures. They are item difficulty index, items reliability index, item validity index, and item discrimination index. So all of these indices propose or produce valuable information for us to evaluate the quality of each of the items as well as its effectiveness in measuring the constructs. So let's discuss on each detail of all of these indices. So the first one is item difficulty index. So what is item difficulty index? Item difficulty index refers to the proportions of test takers who answer the questions, who answer the items correctly. Okay, this item difficulty index, also known as item endorsement index. Okay, the difference is for achievement tests, most test developers use items difficulty index. However, for a more attitudinal or personality related constructs, test developer use item endorsement index. Please do not confuse ourselves with these two names, item difficulty and item endorsement, because both referring to the same thing. Why? Because the formula they use to calculate the difficulty index is exactly the same, regardless whether it's endorsement or difficulty index. It's just that in terms of suitability, because of attitudinal construct, is more of psychological based, personality based, is more suitable to use endorsement rather than difficulty. And in fact, the formula, in order for us to get the proportions, how many of our respondents get it right, how many of we get it wrong. So we just basically need to calculate the endorsement index by looking into the number of correct responses against the total number of test takers. So we will get the proportions of our respondents who get the answers correct. So there is a different interpretations of the different scores of the index. In this case, if we calculate, okay, based on the formula mentioned just now, if we calculate and we happen to get the index which is less than 0.30, okay, 0.29, 0.10, 0.15, it shows or it indicates that the items are too difficult. In other words, less than 30% of the respondents are managed to answer the questions correctly. Okay, more than 70% of the respondents got the answers wrongly. So it shows that the question is too difficult. So what we are aiming for is the difficulty index in between 0.30 to 0.70. So this shows that the items demonstrate moderate difficulty. So as a test developer, we are looking at a quality criteria in this range between 0.30 and 0.70. What we do not want, beside item difficulty less than 0.3, we also do not want item difficulty index to be bigger or higher than 0.70. Why? It shows that more than 70% of our respondents managed to get the answers correctly. So it shows that the items, the question is too easy. So in this case, it's also not ideal. So like I mentioned just now, the ideal range that we are looking at is between 0.3 to 0.7. So why item difficulty index is important in test development? First and foremost, this index gives an indication of test quality. So it helps us in structuring a reliable and valid assessment. So remember, we are looking at moderate difficulty. We don't want to have an item which is too difficult, almost everybody got it wrong, or too easy, almost everybody got it right. So we want in the range of between 0.3 and 0.0. So beside that, items difficulty help us in item selections. Remember, during writing of the test, we generate a lot of items. Okay, sometimes double the numbers of the target numbers of the items, target number of the items in the test. So we needs to reduce these numbers of items. So in this case, the difficulty index that the items demonstrates will give us a good indicator whether we should retain the items or whether we should modify, improve or omit the items. Item with moderate difficulty between 0.3 to 0.7 are most effective, and these are the items that we will retain. And furthermore, item difficulty index also contributes to another index, which is item discriminations. So item difficulty index improve discriminations. Too easy or too difficult items, this will lead to poor at differentiating high or low ability of test takers. So it does contribute to the discriminations. However, moderate items between 0.3 to 0.7, these are the best ideal item at measuring variations in our respondents' performance. So we are looking at the discrimination power. We don't want too easy, we don't want too difficult. We're just looking at the moderate level between 0.3 and 0.7. The second index that we would like to calculate based on our tryout data is items reliability index. So please do not confuse ourselves with reliability of the test. So in here, it highly relates to the reliability topic that we discussed in previous chapters. But here is more specifics in identifying the quality of the items through reliability analysis. So under items reliability index, we can gather 4 types of information. The first one, internal consistency reliability. The second one, Chrombar alpha if item deleted. The third one, inter-item correlations. And the last one, item total correlations. So if you recall back, reliability refers to the consistency of the items in measuring the constructs. And it refers to how we can attribute the scores of the items to the true score rather than to errors. So basically, we are minimizing the error in the measurements. So here, the first index that we can get, the first information that we can calculate for the reliability index is internal consistency reliability. So in this case, we can calculate Cronbach alpha, split half, or Kuder-Richardson formula 20 or formula 21. So beside that, whenever we request for internal consistency reliability, especially Cronbach alpha, we can always request Cronbach alpha if item deleted. Okay, for internal consistency reliability, we are looking at the overall reliability of the test if it is a homogeneous test which is above 0.7. However, if it's less than 0.7 but in between 0.5 to 0.7, some researchers still consider it as an acceptable value for a descriptive test, okay, for exploratory test. And in fact, this is the newly developed test. It can further be enhanced. Okay, and then by looking at the second information, which is the Cronbach alpha if item deleted, researchers and test developers will be able to identify if there is a potential problematic items. In this case, we are looking at the value which is above the overall Cronbach alpha. Example, if you run an internal consistency reliability analysis and you got your Cronbach alpha as 0.75, okay, I repeat 0.75. So here, when you look at Cronbach alpha if item deleted information, you are looking at the figures which is above 0.75. Say for example, out of 30 items, you identify one item number 5, which the figure of 0.80. So it means that if you delete that item, okay, item number 5, your overall alpha will improve to become 0.8. Meaning that without that items, your overall alpha will improve. So this is an indication that that item may be problematic. So it shows that as a test developer, you have to go back and review the items whether it does cause problems or not. So beside looking at Cronbach alpha if item deleted, so we can also observe the statistic of inter-item correlation. Remember, in this part, we have already, if you develop some reverse score items, negative worded items, you already reverse score them. So we are expecting that between items, there should be a positive, a significantly positive correlations. Okay, because there are no negative worded items, so we are expecting all positive correlations. So in this case, if there is an item with negative correlations or with a very low correlation which is non-significant, so this may indicate that those items are problematic items. So we can look further and review the items. The same thing can be applied for item total correlations. What we are expecting is we are looking at significant positive correlations between the item score and the total score or composite score. So if the correlation is negative or very low, non-significance, it may indicate that the item is problematic. So it shows that, okay, all the test developers need to go and review back those items, whether it does carries problems or not. Okay, otherwise we can also consider informations from the other item analysis information, such as item difficulty index, item validity, and item discrimination index. Okay, before I proceed to discuss about items validity index and item discrimination index, I would like to clarify here some informations elaborated and explained in these subtopics, which is item analysis, are based on multiple sources. It's not only based on the main textbook, which is Psychological Assessment by Cohort et al. 2022. For example, information that I just described just now, Chromebook alpha if item deleted, inter-item correlation, and item total correlations. Okay, and considering those multiple sources of information, I don't consider factor analysis under reliability index. Although some textbooks consider factor analysis information or results can indicate or should be reported under item reliability index. Instead, I consider factor analysis under items validity index. The item validity index in this perspective is determined using factor analysis, especially using exploratory factor analysis at the beginning of the test development. So factor analysis helps evaluate how well items represent the intended psychological constructs. So I'm going to elaborate further on why I consider factor analysis as evidence of validity rather than reliability. So factor analysis assess construct validity. How? Through ensuring the test measure the construct as conceptualized. Okay, remember in phase 1, okay, during test conceptualizations, we clarify on the construct, whether the construct is unidimensional, or whether it's multidimensional. If, say, for example, the construct is multidimensional, so how many domains, how many components it has? Okay, say, for example, 3 components, it should reflect in 3 factor structure. So in this case, we are looking at the consistency of the validity indices through factor analysis results. See in here, factor analysis should indicate similar findings, meaning that the data suit the model. In this case, if we conceptualize a construct as multidimensional with 3 components, then we should expect 3 components as well. If we manage to have the same results, consistent results, then it indicates evidence of validity. In what case? In the case of construct validity. Okay. Furthermore, factor analysis provides statistical evidence supporting the theoretical framework of the constructs. This is what I meant by the dimensionality. If the construct is multidimensional with 3 components, then we are expecting similarly from factor analysis results. So, why I consider factor analysis as evidence of validity, especially construct validity, because factor analysis would allow us to assess dimensionality of the test. Okay, although our experts during content validation indicates that all of the items comprehensively represent the constructs, all the items measure the components involved, but these are the perspective of experts and test developer. However, we will not be able to know whether our participants will supposedly carry similar characteristics of the target populations understood similarly with the way we conceptualize the constructs. So by conducting factor analysis, it will allow us to assess this dimensionality to determine whether a test is unidimensional or multidimensional. Furthermore, it will also give us information on factor solutions. These should align with the components or dimensionality. Say for example, we conceptualize it as having 2 components, then we are expecting 2 factor solutions. If we conceptualize it as 3 domains, then we are expecting 3 factor solutions. Okay, we can identify the number of factors from the result of factor analysis. And lastly, factor analysis would able to give us the informations of item loadings, how much the item contributes towards the total score, the variance in the test. Okay, under these factor loadings examines how strongly each item correlates with the identified factors from number 2 just now. Okay, ensuring item relevance and values, which is some consider that they contribute more than 40%. Some consider it contribute more than 30% of the variance of the factor. So in this case, all of these three evidences, dimensionality, factor solution, and item loadings, are the evidence of construct validity because it gives us an indications whether people understood the construct similarly as it's being conceptualized by the theory. And the last index under classical test theory approach of item analysis is item discrimination index. So what is item discrimination index? Item discrimination index measures how well an item, a question, differentiates between high and low scorers on a test. So in this case, obviously we have to identify who is the high scorer, who is the low scorer. When we manage to groups the 27% of top scorer and the 27% of the low scorer, and we can compare their performance on each item. So the item discrimination index ensures test validity by identifying as well as improving items that fail to differentiate effectively between high scorers and low scorers. So if the item have this ability to differentiate between high scorer and low scorer, we call this item as having discriminatory power, which is they are able to differentiate between high scorer and low scorer. A good item is one where high scorer answer it correctly and low scorer answer it wrongly. Okay, that is a good item. That is a good quality item from discrimination index perspective. If, say for example, a high scorer fail to answer an item, so we may need to consider that this may be because of misinterpretation or because of distractors. So this requires revisions or even eliminations. Eliminate what? Eliminate the items, because the items are unable to differentiate between high scorer and low scorer, and in fact it in reverse, in whereby high scorer are unable to answer it correctly. An item is ineffective if low scorer answer correctly more often than the high scorer. So the question is, there are something wrong with the questions because high scorer did not manage to answer it correctly, while low scorers managed to answer it correctly. So these are the symbols and calculations of item discrimination index. So usually item discrimination index is represented by the symbols of D, small capital D. So it compares, this discrimination index compares performance of our participants in the upper and lower segments of the test scores distributions. Usually we take 27% top scorers and 27% of the lowest scorer. So we group them into two groups, high scorer and low scorer, and we compare their performance on each item. So if the items manage to indicate that majority of top scorer get it right and majority of low scorer get it wrong, then we can calculate the discrimination index for that particular item. So when we manage to calculate the discrimination index, then we need to interpret what is the meanings of those index. So higher D values, higher discrimination values indicate better discriminations. So we are looking at towards perfect one, okay, 0.8 and above. Say for example, we got a value of perfect one, which is positive 1, This means that we managed to get perfect discriminations. What perfect discrimination means? That all respondents, or all top 27% respondents, answered that questions correctly, and all low scorers, all low 27% of low scorers did not manage to answer that question correctly. In other words, they got the question wrongly. So this is perfect discriminations. If we got a value closer to 0 or 0 D value, it means that there are no discriminations, which means that between high scorer and low scorer, their performance are equal. Okay, equal performance between these two groups. Okay, in the case that if we got negative D value, -1 for example, it means that reverse discriminations. We don't want items to have this kind of negative D value. This is problematic items. We should modify, revise, or maybe just eliminate the items. Okay, this reverse discrimination, -1 D value, mean that all low scorers answered correctly, but all high scorers answered it wrongly. So that's why I said it's a problematic item. This signal a serious problems with the item. The overall evaluation of all 4 indices, item difficulty index, item reliability index, item validity index, and item discrimination index, usually have a mixed response because all carries its own purpose and all are important. However, in the case that we need to choose, usually items reliability and validity index can be further enhanced. Remember, this is during test development process. So all of the items that we tested during tryouts, there are some good items, there are some problematic items. So hence, you usually will run again validity and reliability analysis when we conduct validation study, when all of the problematic items are removed and we retain only good quality items. So in that case, we will have a better reliability and validity results. So if we have to choose between all of these indices, which one is more important, usually researchers and test developers will have to look at their purpose. Okay, in the case of discrimination and difficulty, because this is used to identify problematic items and on quality criteria, they prefer item discrimination. Why? Item discriminations ensure that the test is meaningful by confirming that higher ability test takers, which is high scorer, the top 27%, are indeed performing better. Okay, as well as item discrimination index detects poorly functioning items, which is, okay, examples given here is the negative D value, which is the reverse discriminations. Okay, beside that, item discrimination as well considers distributions of scores. So they look at overalls and they group the 27% top scorer into high scorer groups. Okay, and they compare the result of top scorer with the lowest scorers of 27%, and they put it in one group, which is the low score. So they consider the scores distributions. So performance in the upper and lower 27% of test takers ensure that an item truly reflects differences in ability and promotes the items to have discriminatory power.